Hey everyone, and welcome to another episode. Today we're talking about gravity. I'm coming to you from Olyphant, Pennsylvania, and what better spot to talk about this than the corner of Gravity Street and Gravity Avenue. Check this out. This is where we are, right here. Let me zoom in a little bit. Gravity Avenue and Gravity Street. Have you ever wondered why when you drop an object it falls to the ground? Or why the earth revolves around the sun and the moon revolves around the earth? Or why there's a rhythmic fall and rise of sea level in the ocean? All of this is because of gravity. We give credit to Sir Isaac Newton in the 17th century for coming up with the concept of gravity. We've all heard that famous story where he was sitting under an apple tree and he watched an apple drop and he questioned this. He said, why did it fall down? Why did it not fall sideways? Why didn't it fall up? But why did it fall down? And this is what he used. This is those thoughts, so the story goes, on developing the fundamental law of gravity. So here's the equation for gravity. It's the gravitational acceleration constant times the mass of object 1 times the mass of object 2 divided by the distance between the two objects squared, as we see in this equation. What does this equation mean? It basically means that the force of gravity increases with the mass of the objects and decreases with the distance between them. You heard me mention in the equation g, which is the gravitational acceleration constant. This value is 9.8 meters per second squared. Gravity is what gives us physical weight. It's what causes objects to fall towards the ground, what causes the planets to orbit around the sun, but what also it does, it allows for the tides that happen on the ocean. Tides are the rise and fall of sea level in the oceans, and this is caused from the gravitational pull of the moon on the earth, and also the sun to the lesser degree, and the fact that the earth is rotating on its axis. Let me explain this more. The moon is pulling on the earth. The water is more fluid than the solid part of the earth, so the water is pulled towards the moon, creating this bulge, basically high tide. Because the earth is spinning, there's inertia, so on the opposite side of the earth there's also a bulge. And then as that earth is rotating in and out of this bulge for any particular spot, we notice the rise and fall of the tides as the earth rotates. It's not just the moon. The sun also plays a role, though not as much. And when the sun, the moon, and the earth are all aligned together, we have the biggest tidal bulges, or the greatest tidal variation. We call these spring tides. When the sun, the earth, and the moon are at 90-degree angles of each other, then we have our neap tides, which is the smallest or the shortest variation between high and low tides. Again, neap tides. Since the earth rotates once on its axis every 24 hours, we can predict the tide. It's almost rhythmic in this rising and falling. Most parts of the world, most coastal areas, have 2 highs and 2 low tides every day. So next time you're out there at the beach or on the coast watching the rise and fall of the water because of tides, remember this is gravity in motion, and you're watching a dynamic process that occurs in our oceans. So a little bit about gravity. Thanks for watching.